Alright, another draft physics video presentation. Yeah, it's not very well produced yet. Anyway, a couple of things. Fractal Woman has made a video critiquing Ken Wheeler on the subject of magnetism, and both of them have, incomprehensibly silly counter space bullshitty explanations for how force functions in the universe. So neither has any clue how magnets work, really. And she complains that there's too much animosity, in the discussion. And one could argue that Einstein was being pretty harsh in saying something like spooky action. Even the Schrodinger cat analogy is sort of making physics look ridiculous. It's pretty insulting, it's, So I mean, he's essentially calling them religious with their spooky action description, just saying, why don't you just make up invisible men? Even though Einstein's theory was, in fact, just making up invisible men. I mean, bent space is not an answer. It's a placeholder for the answer. It's not a mechanism. You can't bend nothing. You can only bend somethings. So first explain what the hell the something is, and then tell me you bent it. But anyway. So I don't know what to say. I mean, obviously there has to be some sort of animosity because, this is sort of important, getting these right answers. And certainly the wooey religious answers, in my opinion, are just insanely dangerous. It's not just that you don't know how to drive, like you don't know how to steer. It's like you don't know the difference between forward and reverse. When you get these fundamental questions wrong about the function of the universe and the fact that it has maybe some redeeming feature somewhere, it's doing something intelligent or even nice, which it isn't. It's just chemistry attempting to squish out all the other chemistry, essentially. It's just this stupid mechanism where you exist at somebody else's failure, period. Things affect things, and it's all shadow, so to speak. Nothing casts any light. But anyway, I don't want to get too philosophical, but so it is important to get the right answers. And wrong answers, in my opinion, are kind of obvious in the sense that, as I've sort of explained in the previous video, these wrong answers are a byproduct of flawed experiments and, quote mining the reality to get what you want it to do, making it what you want it to do, forcing it to be what you want it to be. And so she does a couple of experiments here that, again, just illustrate the danger, how careful you have to be. At least you have to be mindful of how easy it is to make a mistake, to not account for the fact that you are creating variables that you don't realize you're creating, all that kind of stuff. So I'll go through some of the flaws in her reasoning here and take it from there. Yeah. And then I'll do Sean Carroll on time a little bit, probably, or read a comment or something like that. All right. So anyway, as I have described, magnets, in my opinion, can be understood as simple devices, and even if you don't believe what I'm saying about some elements, you could get some part of it and say, okay, I'll accept that, certain little truths. And the fact is we know that the magnet has two fundamentally different elements. The north is fundamentally different than the south end of the magnet, and that if you know anything about charge, you could sort of understand that these things do the same thing as charge does. There's this inverse relationship. So anything northish, okay, is going to be repelled, by the likes will repel, and the dissimilars will attract. And they do so proportionally. That is, there's the same amount of charge, so to speak, in the south end as the north end. You can't make a magnet that's more south than less north. unless you're talking about atomic structures. So the basic mechanism is this inverse relationship that certain things will be attracted and certain things will be repelled, and they do exactly the opposite in the sense that, based on this north-south thing, whatever's attracted to the north end is going to be repelled by the south end, and vice versa. And you can understand certain mechanisms that, certain truths of how magnets function is that it is about exposure. So you could metaphor it to something like light, because the fact is that what the magnets will do is illustrating that they have to see the force. Okay, so whatever this is, this force, whatever you want to think it is, waves or whatever BS you want to make it into, there's an elemental fact, and that is if I put a magnet in here, what it'll do is it will orient itself, okay, with the opposites attracting, and the back end will essentially be swung out of visibility. So the idea is that just like charges, the like charge will be moved towards the same charge. I mean, the like charges will move away, so the white end will move away, the blue end wants to move towards. That's obviously a conflict, and it'll end up orienting itself this way, but it's really orienting itself this way because of exposure. And the fact is that once the white end is hiding behind the blue end, it's invisible. The magnet can't see it anymore. And likewise, this magnet, this blue end, can't see this blue end over here anymore. And that's why it moves in. It's because they're fundamentally equal. Okay, there's just as much repulsive power coming off of one end as there is attractive power coming off the other end, and they're so close together that it really shouldn't technically make much of a difference. But obviously we see a huge difference, and that this magnet will now move towards this magnet very fast because this and this can't see each other. And that's that simple. So it is a force. It is something it has to see. It's not some I detected you through ESP or some other kind of mechanism, and we know this force moves the same speed as light does, so we kind of can look at it as being sort of like a light. And that all you have is that you have this blue light coming out of one end, and you have another color light coming out of the other end, and the simple truth is the two magnetic poles react oppositely to whatever color it is. So if it's the same color, it wants to move away. It feels it as a push pressure. If it's the opposite color, somehow the pressure is negated and it is attracted. Now I would argue it's not attracted. It's being pushed by the rest of the universe that's always pushing. Okay, the universe is always supplying a bunch of this energy, and all the magnet's doing is filtering the energy. That is, it comes in blue and white, and it comes out of the magnet. It's reflected out of the magnet as blue and white. And that's the simple mechanism. And everything can be explained. That is, the field lines that are drawn can be explained in understanding that how the magnet's going to line up to the field and how the magnet's going to turn, just like a compass needle turns. And that has nothing to do, that doesn't change the fact that the force that's causing that effect is a straight line force radiating just like a light bulb. All right, so now we're going to get into the strength of a magnet. So they have numbers, to tell you how strong a magnet is, and what it really has to do with is a density argument. It's like how many magnets per inch. So you're just basically saying take a segment of space and how much magnet is in that space. And so if we said the standard would be for a square inch would be a 52 or a 42, would mean that the difference between those magnets, it's a 4, would be that obviously the 42 squared you could think of as being smaller, or you can just think of it as less blue, it's less dense. Okay, it's not as thick with magnetism as the 52 would be. And these numbers, you'd have to get to 1,000 before you get 1 Tesla of magnetism. So you can say that the difference between 42 and 52 isn't going to be huge, but it should be noticeable. for sure. And so if you have two magnets that are the same size, as is going to be in her experiment, and they're exactly the same size. They're exactly the same size, and you say one's a 52 and one's a 42. Fact is, it just means that that's the density. That means going both ways through the magnet. Okay, obviously, one magnet, the 52, is going to have more. You could think of them as lines of energy. So you can think of it that simply. It's just lines. Okay, that are coming out, sources, you could say, little sources of light. So this one would have 6, let's say, or 5, and this one would have 4. Only 4 lines, or 4 LEDs shining the light. So you could say that they're the same depth, but the depth is also more intensity. So these LEDs not only are brighter, okay, they're shining more light, there's more of them. Okay, so the N52 would, if you understood it as a light bulb, it's not only brighter, but they're more compact. Okay, so there's more of them. There's 52 lumens versus 42 lumens of light, or watts, or however you want to think about it. And obviously the implication of that is any distance, the 52 is going to have a certain pull. We'll say a pull of 1 would be here for the 52, and obviously for the 42 it has to be some lower number. And that's just a fact that you can understand from all gravity, radiation, or any kind of thing that does function based on the inverse square law, and that's well established on this end of the magnet anyway. R cubed on this end, R squared on this end. The north-south end is an unpolluted field, right? That's a simple thing you could understand, right? I mean, should have gone over that with the bigger diagram. You can sort of understand that this end of the magnet is unpolluted by any white, and this end of the magnet is unpolluted by any blue. But obviously, when you get on this side, you're doing both the push, you're doing both push and you're doing pull, so to speak. So for everything you're attracting, you're also sending as much repelling energy, because the objects you're attracting and repelling, we're going to assume, are dipoles. So you're going to be pushing against it as much as you're pulling it towards, blah, blah, blah. And the net result of that is going to be that you're going to have less capacity to affect something at a distance, because you're going to be mixing. So even if you had, so they line up, right? This little magnet lines up in the same configuration, okay, as this magnet to maximize the pull, which would happen. They will turn to do that. But the point is that obviously this white stuff can get to it, and this blue stuff can get this way. And obviously that dilutes the strength, and that's why the field lines go this way very sharply and then curve this way and get much closer. It's because the field is much weaker this way than it is north to south, based on real world events, in the sense that if you allow the magnets to turn, if they can't turn, that is, if the magnet's forced to stay this way, by some mechanism, you force the magnet to stay, not to turn, not to maximize the potential, well, then obviously this will be much weaker, because the blue is going to be able to hit the white, and more importantly, the blue will hit the blue and push it away instead of pull it towards. So that's just a fact. I should be back. So anyway, let's get into this a little bit. Blah, 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 blah. So part of this will be about the pattern in the ferrocell. So again, this is where parlor tricks are not, useful experiments for science. And there's always been these kind of parlor tricks. I mean, kind of, the exaggerated sense. You could even, it'd be another slight I would have against Tesla, is parlor trickery kind of stuff, showy stuff, but it doesn't really get to the core of the function. How does the thing really work? And the ferrocell is a huge parlor trick, kind of thing. It's a distortion. It creates an image that isn't real. It's not really showing you the internal mechanics. It's showing you something else. Let's see, what can compare it to? You could say that you could put a Porsche body on a Volkswagen frame, kind of thing. You could buy a cheap version and it could look just like a Porsche from 10 feet away, or 20 feet away, but it's not. Okay, it doesn't have any of the same function. And yes, you can make something look like something, but it isn't really happening. What you see isn't actually the reality. I don't know how to say that. I mean, obviously you're seeing it. It's a reality, but the image isn't consistent with how that thing is usually produced, you could argue. It's being produced by a different mechanism. So I'll probably talk about, the facts. Like I said, you can do this. I did it. There's videos where I show it. You look under a microscope and you can see what the little pieces of ferro crap are doing in there. And you can see they're not doing any of this stuff. The stuff you see is not what the stuff is doing at all. And it's doing the very traditional, what you would expect iron filings to do. And this is just a way of looking at little tiny iron filings in a way that distorts your perception. So it's like if I put a magnet on, and I put iron filings on a piece of paper over a magnet, I could look at it at funny angles, especially if I made the iron filings very shiny. And I could look at it at funny angles, and I could see different little hills and valleys and different little things. And it wouldn't be really a good experiment, right? It wouldn't be telling me the truth if I'm looking at it at some obscure angle. It's telling me some different truth, a more elaborate truth, not the simple truth of what exactly the iron filings are doing, what the magnet's causing. And so this effect is an illusion in the sense that it's being manufactured out of using thick glass and shining light in a particular way just to shine on certain elements of the pattern. So it's just showing you little pieces of the pattern in a way that's forced by a certain amount of geometry. Well, anyway, so that's detectable, provable, demonstratable. And so all of this canard that there's some light bending or there's a magnetic field that's following these lines, that doesn't exist. It isn't happening that way. So both of them lie in terms of suggesting that this pattern is really illustrating what the magnet is causing. That this effect is anything other than an optical illusion, a bent mirror. It's not giving you the real image. Alright, I can say it, right? There's no point in saying it because these people are obstinate in their wish to force the evidence to agree with their wooey nonsense. But again, there's no denying the real evidence. The microscope doesn't lie. And what else can you say? You do the experiment and you find the truth if you do it right. Alright, so anyway, so she's arguing that Ken Wheeler states something even more ludicrous in that sense that, well, let's just understand how the ferrocell works again. So you just have this piece of glass, and it's just really all you do is have a bunch of little tiny iron filings inside, okay, that don't stick to each other, and so they're free to move around, and they're very small, and they're in a liquid, so they can move, and the fact is they do exactly what a magnet would. If you put the north end of the magnet down, they'll do exactly what you would expect iron filings to do, is they'll just do this pattern. And what they're doing is they're shining an LED. If I just took one LED and I shined it from this direction, I'll see this line. Okay, that's what I'll see. Just this one. No other line, just these two little lines is all I'll see. And what that's really made out of is this spokes, very tightly, you could say there's a whole bunch of spokes,
And what's really happening is when I shine light from one direction, it reflects off this spoke, and then the light that's a little bit different reflects off this spoke, and the one that's a little different reflects off this spoke, and the one that's a little different reflects off this spoke. So it ends up looking like a curved line, but it's really not a curved line. It's made up of a bunch of straight lines, okay, that you could just, two parallel, you could just draw these little triangles, and it's all a very straight line geometry that's creating this curved line. There's no curved line. The spirals from the magnet are all straight lines. The light is all straight lines. And you're just talking about intersection points. And that's all there is. And so it looks curved, but there's no curve. You're just seeing reflections from specific points where the angles are the right to get back to your eye. Your eye demands a certain angle. And the only places the angle is right is on that curved line. So it's all straight lines that are creating it, even though it looks curved. So the curve is just an illusion. Nothing in the mechanics is using a curved line. So there's no curved line in here at all. And the truth is that's what you'll see. You'll see this one line essentially. And each LED creates another line, so you can understand that if you just keep putting a bunch of LEDs in here, you'll create a bunch of these little curved lines. And if you put enough of them in here, the little curved lines will meet each other and create these little flower design, and that's all, but it's not made out of any curved lines at all. There is no flower in the magnetism. None of that crap is the reality. Okay, it's just all nonsense, really. Parlor trick bullshit. It's not the truth. There's no flowers. There's no burloids. There's no anything swirling about in there at all. Alright, so back to the strength of the magnet. So we're doing the magnet argument first. But the point is Ken Wheeler claims that he made a solar one. And he's making the claim that it didn't have obvious holes where the light goes through. So he's saying that somehow because he let light in from all directions. Alright, and he had no feature that forced the light to be in directed points. At least he's implying that. He doesn't overtly say it, but he implies that he's letting the light in just plain. Well, if you let the light in plain, you won't get any pattern at all because those angles won't matter anymore. Because you're just flooding everything with the same light, and the geometry you won't be able to just highlight this spot, this spot, this spot, this spot, this spot. You'll highlight every spot, and so you'll just get a pattern that'll have a dark place in the middle and then a little light fluffy part here, and that's it. That's all you'll see, because you can't see the individual little rays. You can't see the iron filings. These are little tiny ones. So you'll just see the rays as just a smooth pattern of object. There's something there. It's reflecting the light, but you won't see any directed reflections. So Ken Wheeler is lying. I mean, there's no other word for it. He's deceiving people, and you only accomplish deception, in his case, through deliberate playing with words. All right. So moving on. So she claims she bought two different kinds of magnets, an N42 and an N52 of the same size. Now the first thing you got to say is, well, you bought them from who? A Chinaman? I'm sorry. Yeah, you bought it from some place that probably doesn't really care if they lie. I mean, they don't care if they get away with it. Because what are you going to do about it? Complain? I mean, frankly. So the truth is you bought one eBay auction, you bought some magnets that said they were N42s because the guy was being honest, and then you bought some that the guy said were their N52s, and he just lied. They're the same magnet, they came from the same plant, they're the same thing, and he just snookered you. That's all that took place. But anyway, let's move on to how we know okay, that she ain't doing this right. Alright, so she measures it with her meter, whatever the hell it's called.
The Hall sensor that I used.
The Hall sensor. And she says all her magnets come up with the same number when she places it on the magnet.
Well, that's an indication that all your magnets suck. Or I don't even know how it's even possible, because she should have all kinds of different size magnets, and there's no way you can get the same reading on every single magnet. That would be a preposterous coincidence. So either your sensor is failing, when it touches a material, or you're doing something wrong. And certainly you should be able to figure out that you could put a piece of paper or some other mechanism between a piece of cardboard and measure 1 millimeter from the surface of the magnet on all the magnets. And if it's the same reading at 1 millimeter distance, then you have an amazing coincidence that all your magnets have proportional size to their weakness or strength. Like somehow all her really small magnets are really strong and all her really big magnets are really weak in exactly the same ratio, which is an insane coincidence, frankly. It just doesn't sound possible that you could have purchased magnets that are proportionally, like I said, all your big ones are weak, proportional to how, and all your small magnets are incredibly strong. But that's the only way you could get the same reading.
My other experiments and discovered that both the N52 and the N42 had a minus 1.44 reading.
Which means they're the same magnet. Okay, same size magnet, same reading, same density of magnetic strength. So it's telling you right there, you don't have two different magnets. You have the same magnet
on the surface.
All right, because frankly, yes, if I had a 1 Tesla magnet, that's what you would measure on the surface is 1 Tesla. It wouldn't be 1.4. It would be whatever, 10.1 or whatever the compensate reading would be. The reading is an indication of the strength of the magnet. And again, the only thing you could be doing is maybe forcing it to touch the surface, is screwing with your sensor a little. But beyond that, like I said, just do it from 1 millimeter on every magnet. And if you're getting the same reading for every single magnet, then something is way wrong with your sensor.
So at least at the surface of the magnet, as I measured all my magnets.
I mean, all of them are all the ones that were the same size. So all the ones you have that are the same size are the same N number then. But if you're saying that every magnet you've ever put that sensor on, you get the same number, then your sensor is a piece of crap.
All my magnets have a minus 1.44 voltage reading. At the strongest reading is minus 1.44.
I think she's just misphrasing this. She really doesn't mean all her magnets. I think she means all the ones that you bought that are the same size. And guess what? Yeah, they're all the same. And so in spite of what they told you it was, they're all N42 or N35 or N something. But they're not different magnets.
At the surface of the magnet. So there's the N42 and there's the N52, and they have the same identical reading.
Then they're the same identical magnets. So you're done showing the difference between two different kinds of magnet because you have the same magnet. All right, so next.
0.03 reading was in exactly the same spot.
Right, so this is another giveaway, that at the same distance from the magnet, in the same position, and you get the same reading, that means they're exactly the same N value. That means that's exactly how they would test a magnet to see what its N value is. This is exactly the test they would do. And if you have the same place with the same value, then it's the same density of magnetic strength. Those two magnets have to have the same N value. What it is, I don't know, but they're obviously the same N value. So anyway, so then she goes to do it even further to prove the point, which is to put a little ball bearing and mark where the ball bearing is, when it starts to roll. I think that's, well, I guess she's still doing N values or something. Let me see what this part is.
I slowly move away from the magnet.
Right, well, this is how she detects it.
That reading.
Right. Well, it doesn't matter, how you do it. The point is the readings are the same. The end, they're the same magnet. All right. So then she goes. This is the part where she's got the little ball bearing, and this
I'm going to do the same
nice
thing.
simple
So
experiment.
The point.
She pushes it away until it has no resistance. That is, so the point where she can drop the ball bearing and it doesn't move towards the magnet. So she's again measuring pretty directly in a mechanical way, doing what the Hall sensor is doing, just measuring the strength of the magnet. And obviously we have the same size, the same volume of magnet, same weight of magnet, and if it has exactly the same pull at exactly the same distance, then obviously they're the same magnetic density. They have to have the same N number. So, I mean, she should have figured this part out, right? I mean,
then I would be able to bring this ball bearing in a little bit closer to this magnet before, and it should stay there.
Right, that's exactly right. If it was see, she's trying to prove that Ken Wheeler says that somehow the stronger magnet doesn't reach as far. That somehow it's confined in how much its power can go. And the rules of magnetism are the rules of magnetism. You can't change them. There's no variation. The stronger magnet, like a light bulb, the light goes farther. More light, you can sense more light, detect more light at a greater distance. The brighter the light is, the greater the distance I can see it. Just like a lighthouse, right? I mean, there's no magic there. The stronger the light in the lighthouse doesn't mean faraway ships can't see it anymore. No, the faraway ship can see it better. I mean, it's that obvious, and to even have to argue it is almost silly. When you think of the volume of experiments that have already done to prove all this stuff. But the fact that she's not getting it, that she has exactly the same amount of force at the same distance, that she just did the test to figure out what the N value of the magnet is, and she just doesn't have a control. If she had a control magnet here, of the same size that was an N35 and that was already established, then she could say, oh, well, this is an N37 or this is an N53. But if it's the same value, it's just telling you, yes, that's what it is. So you can't say N52 pulls just as much as an N42. So she's countering Ken's theory by pointing out how two different magnets have exactly the same pull. When, no, you're already demonstrating how you don't even understand the concept. Oh, anyway. Pretty bad. Pretty big mistake. So anyway, I mean, obviously, if a scientist was going to go test a magnet, this is exactly how he would test to say what's the value of the magnet. And he would obviously just say, oh, okay, they pull exactly the same at the same distance. Oh, they're the same value magnet then. They're the same dimensions. Obviously, I could cut this magnet in half, and then it would be much weaker. It would be half as strong, frankly. So the ball bearing wouldn't be pulled from here. It would have to be much closer before it would get pulled if I cut that magnet in half. But we're just talking about the density of the magnetism, and obviously the same volume gives you the same density. So if you get the same reading with the same volume of magnet, same weight of magnet, then the magnets are of equal density, and they can't have different N numbers. It's not possible that they can have different N numbers. And so she should be able to figure that out. So moving on to the ferrocell. So here she says her two different magnets, right? That are the same magnet did show different results under the ferrocell. Now the problem with these experiments is ferrocells burn images in, so when you do something with a magnet, it has a memory. It doesn't completely erase. All the little iron filings don't go back to where they originally were or anything like that. They kind of stay in the local vicinity you've pushed them into. So certainly if you tested the N42 first and then you did right after it, you put an N52 under it, the N52 would be taking advantage of what the first magnet did. And the second argument that's kind of obvious is it's all about how fast you move the magnet in, just it's all about how fast you pour on the iron filings and all of that kind of stuff. How you apply the forces will dictate how much the little iron filings can move. So the slower I move the magnet into the ferrocell, the more time the little bits have to move, and the less likely they are to bang into each other and get clogged and get stuck. So I'm going to get a better I'm going to get a better image, quote unquote, the slower I move the magnet in. It's going to give it more time to show you the right picture. So that's also very deceptive. So I would argue that this is not really possible if the other experiments already demonstrate that these two magnets are the same strength. And so this, again, is quote mining. You made a mistake in how you tested this. And that's the simple argument. Okay, and then she does this computer monitor thing. Now, I can't say that it's got the same vulnerability to, the image being more likely to be reconstructed, because it all depends on how exactly this CART screen, this old tubed TV screen she's using, is constructed. Color monitors have a screen, a metal screen, right behind the glass. So obviously the magnet's affecting the metal screen, and so it gets into a whole bunch of stuff that you've already got some residual magnetism in the screen, blah blah blah. And maybe it is a more subtle. Maybe it can detect more subtle differentiations in the magnetic strength. Like the ball bearing has a limited ability to give you really small increments. Like it can only measure inches. It can't measure millimeters in terms of difference. So it's kind of clunky. So one could be like an N52 and one could be an N54. That kind of thing. And that the computer monitor might be a little better at detecting subtle differences between magnets. But that's all this is. I mean, the differences are small, and between the two images, you can sort of see the little bit of difference, a little bigger, a little twist is a little different, but also has to do with how you place the magnet on the screen, north-south versus south-north, all this kind of stuff. So we don't know how careful she was about that beyond putting a piece of tape on the screen. But anyway, I would argue not a very convincing demonstration of the difference between N42 and N52. There should be a bigger difference between those two magnets. And that should have been another giveaway to her that her magnets aren't what they say they are. Not what like I said, I mean, everybody buys magnets from China now, I think. So, not a very reliable source of labeling. They might try to fudge the truth a little bit over there, right? So you might not be getting what you think you're getting. It might not be a Porsche. It might be a Volkswagen underneath. Anyway, all right, so this is where she gets to the other...
that Ken talks about in this video, and I'm just going to play the clip, and then I will talk about it in a minute.
Yeah.
So of course you can see the donut shape. There's nothing here, by the way. This is not a projection device. This is literally just LEDs, like for the edge lighting of your cabinet. So there's just light shining inwards. By the way, about 2 years ago, people said, well, you're just looking at the number of lights here. It's like, that's not true. I created one of these.
So he says that's not true when it's overtly, explicitly true. You can count them. Again, for every LED at the perpendicular, there's a curved line. And as I pointed out, the curved line is really just lighting spokes of the radial line you can see with a microscope. You can see it. You can see exactly how the little bits are lining up. I've shown the images. I videoed it. It's not a debatable point.
These devices where the light pours in from the sun, so only one light source. So the sun was...
So he says only one light source, but the truth is he had to have holes drilled in it. There's no other way it could work. He had to put holes where the LEDs are. So yes, you have one light source, but obviously you're converting it into numerous light sources by putting holes and putting a blocking material with holes in it. I mean, it's that obvious. I mean, I can do that right here. I can put my hand up and block some light with my fingers. It's going to give a different pattern on me than if I just let the light in. Everybody knows that.
Able to wrap around an antenna-like structure and shoot inwards into the cell, and you get the exact same thing from a single light source, which is the sun.
Okay, so it's not a single light source. So right there, that's the deceptive words. He says it's a single light source as if the same amount of light comes from all sides of the glass. That didn't happen. That's a lie. That's bullshit. So he's just a liar, right? There's no reason for him to argue this point because he knows the truth. And the person who raises the point that there's just a line for every one of the LEDs is absolutely correct. And there's just no way to argue any other way with any kind of credibility. You're just lying if you suggest any other fact is true, because it's a fact. I videotaped it with one light source. There's only one curved line. That's all there is. I move the light source. I move where the curved line is. It's just not that complicated. So, the fact that he gets away with this crap is really depressing. He gets thousands of views to just spout crap that isn't true. But then look at this. Look at what she does to this. She compares this to this fake picture of a black hole that isn't a photo, that isn't anything like a picture, that's also just a piece of parlor trick crap. And oh, look, there's a similarity. Black holes are just like what magnets are. And it's nothing like it. I mean, there's nothing to compare. They're so dissimilar. It's just, you just sit here and this, it's futile. But anyway, the point is, she's obviously pointing out that there is no lines now, okay? I have a continuous source of light, and her continuous source obviously isn't perfect, because her continuous source is still relying on fiber optics to put the little... So it still has a little point sources, so the little tiny ones, you don't see it as much, but it's probably got some. You can see a little bit of a jaggedness, and so that's just sort of it's not a perfectly even light source. But regardless, the point is made. There's obviously not a whole bunch of lines swirling around. There's no spirograph pattern, none of that. All of that's gone, because it really is all about just reflecting light off the very, off pieces of, it's all about taking advantage of the positions of the little mirrors that become the ferrite in the ferrocell. The ferrocell has little tiny mirrors essentially in it, and those little mirrors reflect light, and it's all about where the light, what angles the light can get to your eye. Alright, anyway, so enough. I mean, it's just, this is just garbage, junk, stupid, retarded, silly science. So her closing statement is, it appears that some of the things you are repeating in your videos are incorrect, especially regarding spectral reach of stronger magnet. Well, you didn't really demonstrate that because, frankly, your demonstration was that somehow the spectral reach of an N42 magnet of the same size as an N52 magnet is somehow the same, when it's not. It's not. And you should be able to know how that's not possibly, that can't be the right answer, that the two magnets would have the same profile. Then if I had a 1 Tesla magnet, it would still have the same profile, or a 5 Tesla magnet would have the same profile. I mean, you should be able to know that you made a mistake there somewhere. Alright, display, okay, so reach of the stronger magnet and the display of the ferrocell under continuous lighting conditions. Under even would be the point. You may want to consider repeating the experiments. Oh, so she suggests he should repeat something. When you know, and I know, and everybody knows, he made the device. He knows he had holes in it. So he doesn't need to repeat it, because he already knows. And he's just pretending I don't have to reveal that information. I can just talk around it and pretend that isn't a fact when it's the most glaring fact in the experiment. It's why the experiment worked, is the fact that you drilled those holes. Anyway. So anyway, it's just, either way, garbage, smelly garbage on top of smellier garbage, frankly. Alright, now, do I bother with Sean Carroll, or do I just do a comment and get the hell out of here? I mean, this whole time dimension thing, I just don't know whether it's even worth going through it again. Time is just a function. All of these drawings he does of the they're fake. They're not three-dimensional drawings. It isn't, he draws a two-dimensional plane and then puts time going up, and you just, well, slices of time in the two dimensions. You obviously can't do it in 3 dimensions, because then everything would have its dimensionality would just be in the direction it's moving. Time only has only exists in the direction something's moving, which would be silly to think that time only exists in my personal slices of directionality. I mean, but anyway, it's just too stupid, so we won't bother. Maybe some other day, I don't know, when I could give a shit. So maybe we'll just deal with this comment and get the hell out of here. There is no woo. So Jerry just keeps making these, veiled, weak-ass attempts to defend conventional physics and doesn't answer a single point I raise. So he has no response to all the points I point out about how their theory can't work. So I ask a simple question. Einstein said you would never see an Einstein ring in space. Why was Einstein wrong to think that you'd never see it? Because it'd be too weak, too small, too thin. Why is that theory now invalid? And we're going to say we have photographs of Einstein rings when Einstein said it wasn't possible. Why don't you just explain? How does the wrong shaped lens, that is a lens that can't slow light down, and a lens that is the wrong shape, I mean, just completely backward from a magnifying lens, how does that lens magnify a distant object? Answer my questions. But no, you don't do that. Alright, you just keep doing this silly crap of rephrasing their garbage to pretend it's not just made up shit. It's just made up shit. Okay, their whole wave interference theory, I've completely debunked it with a particle mechanism. I've explained how it works, what's really happening. You have no counter argument that that theory can't work. That simple theory that doesn't involve any stupid ESP between photons. And clearly, I've debunked theirs in the sense that it can't be true. Because if you do it honestly, these experiments, you'd figure out that the radar one is just jamming. There is no, the waves do not interfere with each other. And I pointed out the experiments they could do to prove that. Anyway, it's there is no woo. The whole frickin' thing is covered in woo. What do you mean there is no woo? Entanglement isn't woo? It's just that we need another way of thinking. See again, why? Why do you need it? I'm pointing out how you don't need it. That it's the obstacle to you getting the right answer is your will to force the universe to be something it doesn't show itself to be in front of us every day. Everyday events, the stuff in this universe, in my universe, doesn't do any of this horse shit they say exists. Why doesn't it do it? Because why would I think something else does it? Only in the place where the things are too small to see, all the magic exists. Isn't that just convenient? No magic here. No, only there. Alright, anyway. Another way of thinking when we're dealing with elementary particles. Well, you don't even know what a particle is, so again, you can't rationally define any of this stuff. So why don't you say elementary wavicles, because that's what you really believe in. You don't believe in particles with momentum. You don't believe in momentum as a concept. I mean, the whole universe is screaming to you that there's only 2 things in it. Okay? There's bits moving the speed of light. Okay? There's quanta. This is called quanta. It could be a wave. It could be anything you want to make it. But the point is it only transfers its momentum at the speed of light. And we know that magnetism is doing it. Gravity is doing it. Light is doing it. And the nuclear forces are doing it. Everything's doing this. See, traveling a distance, going from point A to point B in a straight line at a set speed. That's one thing in the universe, is this quanta of momentum. And the other thing in the universe are these bigger things that obviously get hit with the quanta, they absorb the momentum, and they move much, much, much slower. Okay, very, very, very less than c. Okay, much, 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 much less than c. Because obviously the quanta has to be spread over every other little bit inside of the object to move it.
Okay, so its mass has to essentially have this quanta hit it, hit it, hit it, hit it, hit it, spread it out over all of this stuff to move all of this stuff a much slower speed. That's what the universe is screaming the truth is. There's momentum moving the speed of light, we call that a force. And then we have stuff that gets forced, and that we call matter. That's all there is. Force and matter. Nothing else. No entanglement, no anything else. If you want to talk to something, you got to talk to them with these quanta. You have to send the quanta, and the quanta have to come back again. That's the universe is screaming. That's the truth. And you're saying for some, you have some good reason to doubt that's all there is to it. You don't have any good reason. In daily life, we can see their average behavior. So their average. No, we've already done this, right? Einstein got the Nobel Prize for pointing out the fact that it comes in clumps, the force, little quantas, little clumps of momentum. You can look at an object and can look at it the same time and see pretty much what you see. So that doesn't make any sense. You can look at an object and I can look at it at the same time and see pretty much what you see. Well, why wouldn't you see if you were looking at from the same point of view? Obviously you could see exactly the same thing, but obviously you're seeing, both of you are seeing by watching quanta move. The quanta has to move from the thing you're seeing to your eye, and it takes time for it to do that. So obviously whatever you're seeing is information that's a little bit behind what is actually happening. Alright, a red balloon perhaps. Nothing strange about that. In classical physics, so again this bullshit word in classical physics, as if they somehow modernize physics. They didn't modernize anything. They just decided we're going to turn everything into waves and wishy-washy, wooey little nothings. They don't even have positions anymore. They don't know where they are. They're terribly confused. You didn't change any of those fundamental facts. Einstein did not change the inverse square law. All right. Anyway, physics. Nothing strange about that in classical physics. The world is independent of the observer. It's not independent. Obviously, observation is the whole argument here, is that you can't observe little things without screwing them up. There's no photons to bang off of photons. So that's an obvious limitation in our observing of things, is the fact that observation is energy. Okay, but we can't study individual building blocks in the same way. Well, you can model them in the same way, and that's the big argument. Yeah, of course we can't see them, but we can model them. And the fact is the model screams that this is all there is in the universe. There's force, and then there's the stuff that gets forced. And the force obeys strict, straight line, quantized momentum rules. And those rules work. They don't fail. They've just pretended we don't understand. They had there's an interference pattern. There's an on-off pattern. I must call it interference because that's the only way. I every time I see on-off, I have to call it interference pattern. When on-off is the simplest pattern in the universe and can be explained by lots of different mechanisms. Anyway, but we can't study individual building blocks the same way. How atoms behave depends on what you do with them. How everything depends on what forces are applied to it. Nothing goes a crooked line unless a force acts on it. Simple fact. Or unless it has an internal engine that's, on a time cycle and forcing its direction change. You have to change the energy level, so that's just mushy talk. What does that mean? You have to change the energy level. The energy is the force. So you have to affect it with a force, of the electrons to observe anything. So again, whatever. Obviously, we can't see photons. That's the whole point. And the way we see them is because of their quantized effect on an electron. But we can understand that that is a
quantized effect, that electrons don't move the speed of light, that electrons don't do what the little bits do. All right. You have to change the energy level of the electrons to observe anything. In other words, to do something with the photons, well, whatever this to do something with garbage is. The photons are a force, just like any other force moving the speed of light. It's no different than gravity, magnetism, electricity, all of these things, all the little bits moving the speed of light are force bits. It's not possible for two observers to do this exactly the same time. So again, this is so irrelevant. What you're observing has absolutely nothing to do with it, in the sense that we already know that observation takes time. That you're only seeing something by bouncing something off of it, or by it emitting something moving the speed of light, a limited speed. You have no instantaneous knowledge of anything. Okay, your observation will be independent of mine, even when we look at the same thing. Well, obviously, if we're looking at the same thing, we're seeing different photons, because we have different eyes in different places in space, and they're going to collect different group of photons. So obviously, we can't see the same thing, because we're seeing different reflections off of the surface, different rays of light. We might get completely different results. So by completely different is where I'd say, well, that's obviously nonsense. It can be hard to accept if you feel that a red button is a red balloon is a red balloon. There's no reason to doubt the red balloon is a red balloon. There's no reason to doubt the small universe is just as dumb and simple as the big universe. It's just simple things following simple rules. And you're the wacky religious people who just want to pretend that your silly wacky story has something to do with reality, because you want a more interesting universe. You don't want to be a robot. Okay, you don't want to be dictated by these simple mechanical forces. Simple mechanical force, frankly. All right, this was such an ironic statement. It was just so funny. So this is on the video pointing out all of the experiments that should have been done better, that have never been done well, like the Eddington experiment, and pointing out all the other experiments that can be done to validate their physics, their claims. Right? And he calls it, so he says intestable, which isn't a word really. I mean, it's a word about competence to sign a will, for fuck's sake. You should have said untestable. But again, the whole point is these are the tests. Why weren't these tests ever done? If you're sure you're right, why are you afraid to do these tests, right? Why don't they use a satellite in space to take some pictures close to the sun? If you're sure you're right. But anyway. So, yeah, goodbye, stupid, idiotic comment. It's just so ironic to talk about untestability when I'm pointing out all the tests. You know, did I leave out some important test somewhere? I mean, there really isn't anything, right? The whole theory is based on this thinnest evidence, right? The whole idea of gravitational lensing is based on Eddington experiment, which is crap. The rest of the experiment's all about scatter, so you can't separate scatter from gravitational bending. There's no way when you see the photon to say, oh, it was bent by gravity, or oh, it was bent by scatter. You can't tell the difference. So all of those are useless. And the rest of the gravitational lensing images, I've already pointed out how they're all impossible. They're theoretically impossible. Their theory doesn't even fit the image. They can't draw you a picture of how the light rays are reflected or are refracted by the gravity and come to a focus on Earth. They can't draw you a rational picture that has the accurate lens in there, a gravity lens. Because a gravity lens does exactly the opposite of a magnifying lens. Anyway, I've already said all that many times with no response. So it's just, you know. So anyway, I thought you had some little crappy comment here at the end, Jerry. Did you edit this? Yeah, you edited it. But yeah, you shove it up your ass. Okay, you took the little snarkyism out. Okay, fine. So I'll just delete this piece of shit instead of block you. But I really don't need this shit. You want to keep making these weak ass, lame defenses, and you don't ever answer any of my questions, and you think that's fair. Well, fuck that. That's bullshit. And again, you didn't cite a single piece of hard evidence for any of this woo. What's your hard evidence for entanglement? What's your hard evidence that LIGO can measure 1/10,000th of the distance of a proton? When I've already pointed out that their mirror can't even do that. Their mirror is not sensitive enough for that. Their mirror can't detect 1/10,000th of a distance of a proton. The variability in terms of how deep the light goes into the mirror each time. Do you have a theoretical explanation how their mirror is so perfect that each time the light reflects off the mirror, it reflects off exactly the same space in space, the same exact location in space? Can you theoretically explain how the device could possibly measure something when when the ruler keeps changing size? How can I keep changing the size of the ruler and then say you're going to use that ruler to measure 1/10,000th of a proton when you just change the size of the ruler? How can it make any sense? Oh, and the Louisiana guy, maybe I'll block him instead. Would it be wrong to assume magnets on a small scale behave the same way as on a large scale? Yeah, sure. But do you understand the implications? Magnets, like I said, in certain directions, certain orientations, their field diminishes even quicker than r squared. And so you're back to the distance arguments. You understand that the sunlight on like Saturn, the light coming from the sun is really, really dim. It's like 7 o'clock at night here or something. You know what I mean? It's like sunset. They're getting so little sunlight. And the same is true for gravity and magnetism and all these other forces. They get really weak with distance. So they really couldn't do anything at the great distances in the space. In space, things are really far apart. Galaxies are little, they're so tiny compared to the distance. So if you tried to draw them to scale, it's like me drawing two magnets here. I could draw a big magnet and I could draw a small magnet. Well, if I tried to draw the distance of galaxies from each other, both of them would end up as little dots in the picture. I can't, the distance is so great. And even if I did this magnet experiment, the two magnets right at 1.5 feet away from each other wouldn't have much effect on each other at all. Very little effect. Anyway. Behave the same way, okay. It would somewhat explain why our local cluster, so this is the kind of bullshit. These assholes think they have real evidence of something in clusters of galaxies. They're moving so slow relative to our position and the distance we are from them. We can't even see them. We see them as they were billions of years ago. Do you understand that? We're not even seeing them where they are today or anywhere close to where they are today. Anyway, are being pushed towards what science calls the Sharpley supercluster. Not science, okay? So again, don't blame every little one of these little papers somebody writes about some little stupid thing and say all of science believes that, because they don't. None of this shit has been scrutinized. So, they don't know shit. They don't know whether galaxies are getting bigger or smaller. They don't know any of these things as real answers. If not magnetism, what would be pushing us in that direction other than galaxies? So just more rubbish. There's only, magnetism is irrelevant on the big scale of the universe, and you can sort of detect that with a compass needle right here on Earth. The magnetic field of our entire Milky Way is so lame that it doesn't force the needle to move in any direction at all, and the Earth field is what we detect. And there's no way to create any kind of other default. So the Milky Way galaxy is much, 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 much weaker than the weak magnetic field created by the Earth itself. So it can't be a player in any way because the field is so fucking weak. Well, anyway, there's just no point. It just keeps, I don't do galaxy crapola here, okay? This isn't about the big universe. The big universe is a big fucking bore, all right? And all the only thing that makes it at all interesting to people is all their made-up little black hole bullshit. But if you got rid of all of that, the whole thing is dull and boring as fuck out there. The real game is understanding how a magnet works and what a photon is, and that's where physics is even more catastrophically failed. And that's what you should be paying attention to. Wasting your time contemplating the motion of the galaxies is just that, a colossal waste of fucking time. It's just gravity. Ugh. Okay, it's in Zohar's. I had a little bit of a conversation with some asshole about something, but whatever. Yes, people are rude, and it's not even rude. I don't mind rude. They're just lying. I mean, the irony, again, of somebody saying untestable when I'm just reciting all of the tests you can do. I mean, how can you call that untestable when you're talking about the very experiments themselves and doing things to change the experiment to glean more information? How could any rational human being on Earth object to having more information, more data? Amazing. Anyway, enough of the video. I must continue to endeavor to persevere. It's just, it's just fucking so depressing, this fucking planet of the idiots.